Point slope form of linear functions. Okay, so we've actually done two different forms so far. We've done slope intercept form. That's in that y equals mx plus b, where you have the slope and you have the y-intercept. We've done standard form, where it's written like this, and there's a couple different ways, a couple different methods in which you can graph it. And now the third form is point slope form. So point slope form is written like this: y minus y1 equals mx minus x1. So I'm going to get into what exactly that, how we use that here in a second. But this form can be useful. What it says here is this form can be useful when a point in a line is given and the y-intercept is not easily determinable. So like the y equals mx plus b is great. It's great. But it has this catch in where you need to know what the y-intercept is. Now in point slope form, you don't need the y-intercept. You just need the slope and any point on the line. It doesn't even matter. You don't need the y-intercept. You can use any single point, which makes it really, really nice. So number one says this. It says write the equation in point slope form for the lines with the given slopes and point. Okay. So I'm going to referring back to this pink highlighted part I have up there. So on A, we have 2 comma 7 and m equals 4. So if I'm going to write this equation in point slope form, I'm going to call this like my x1 and my y1, because that's the point. And then I already, this one says m equals 4. So this is how I'm going to write it. I'm going to write y minus 7 equals m is 4, parentheses, x minus x1, and x1 is 2. So that's it. That is the equation written in point slope form. If you're given a point and you're given a slope, you can write the equation in point slope form. Simple as that. So on B, I have this point here. I'm going to call this x1, y1. So I'm going to go y minus y1. Well, y1 is 4 equals m is 1/2. Parentheses, x minus x1. Now here, be very careful because x1 is -1. So if we go minus -1, I'm going to write a plus, because when you subtract the negative, it's like adding. So it's plus. So sometimes some people like to say this. Instead of saying y minus y1 up here, they like saying y opposite the y1. On here, they say, instead of saying x minus x1, they might say x opposite x1. So when like down here, that might have been helpful, because if it says -1 here, we could say opposite -1, and that's why we have a +1 there. But you're going to be shown plenty of examples in this. So if you don't quite get it, hopefully you will in a second. So I'll let you try C and D. 2 says, write the equations for the following graphs in point slope form. Remember, you can pick any point in the graph. So here we go. Let me pick any point in the graph. I'll just pick this. So this point is labeled at -2, 3. So I need a point and I need a slope. That's why it's called point slope form. So now let me also try to calculate the slope here. So the slope looks like it's going, let me erase this -2/3, and I don't want to write over that. So my slope is going up 1 to the right 3. It's going up 1 to the right 3. Okay. So my slope, so I have a point, and my slope, my m, is 1/3. So y minus y1, or y opposite whatever the y1 is, to be y minus 3, because like this is my x1, y1, so y1's 3. My slope is 1/3, parentheses, x minus x1. Well, x1 is -2, so I'm going to put +2. And that's how it goes. So you find the slope and you find a point, and you just put it into that formula. That's really all it takes. And just an extra comment here, like when I was talking about earlier, point slope form is really beneficial because like right here, we don't know what that y-intercept is. We don't know what the y-intercept is. It doesn't cross nicely here. So we don't know what the y-intercept is. So it's harder to use the y equals mx plus b, the slope intercept form. Okay. So now let's take the equation and graph it. So what we're going to do is we're going to pull the slope from the equation. We're going to pull the point from the equation. So the slope, our m, is 2, right? Because that's right there. And then the point would be, remember that this is our x1 and then this is our y1. So the x1 would be 1 and the y1 is 5. So there we have it. We have the slope and we have the point. So the point is going to be at 1, 5. So I'm going to plot that there. And the slope is 2. So I'm going to go up 2 over 1. So that would be here. And I'll go back in this direction as well. And there we have it. Now looking on B, the slope we know is negative 3/4. And the point, we have a positive 3 here. So we opposite of that would be negative 3. And then the y is 4. Again, since that form, the point slope form, it's got that x1, it's got the minus y1 minus x1. It's always the opposite, right? So since this was a positive 3, we're gonna have a negative 3, and since this was a negative 4, it's a positive 4 there. It's always opposite. So our point is at negative 3, 4. And then our slope is negative 3/4. So that means I'm going to go down 3 over 4 from that point. Down 3 over 4. Maybe I'll go in this over here as well. And that's the line. Why don't I just show one more actually? So in here we have the slope is 1/2. And the point would be at positive 3, negative 1. Positive 3, negative 1. And I pulled the opposite of that, be a positive 3. And then opposite of that, negative 1. So our point's at 3, negative 1, should be here. And our slope is 1/2. So I'm going to go up 1 over 2, up 1 over 2. There's our line. Okay. I'll let you do the rest on this page. So number 4 says, write the equations for the following tables in point slope form. And remember, you can pick any point in the table. So again, all we need, remember, it's point slope form. So we just need a point and we just need the slope. So let me get the slope first, actually. Let me get the slope. So let's see this pattern here. It's going plus 3, the rise over run over 1. So, it's going, oh, no, it's not. It's not going plus 3. It's going down 3. What am I thinking? So it's subtracting 3, and it's going 1. So the slope, our slope, negative 3 divided by 1, rise divided by run. Our slope is negative 3. And then we just have to pick a point. Any point. It doesn't matter. So why don't I just pick, I don't know, pick this one. 7, negative 8. So I got my point, and I got my slope. So now I can write it in point slope form. So it's going to be y minus y1. So since it's negative 8, it's going to be positive 8. Slope is negative 3. Parentheses. X minus x1. Well, x is positive 7. So I'm going to write x minus 7. And that's the line. The equation for the line. So I'll let you do 4B. Number 5 says, write the equation of a line in point slope form that goes through the following points. So it kind of gives you a hint here. First, you need to calculate the slope of the 2 given points, and then just pick either of the 2 points to write the equation. So again, it's called point slope form for a reason. We need a point and we need a slope. And it's nice on these ones because it actually gives us 2 points. So we're going to get to choose which point we use. But we need to find that slope first. So remember, slope is just rise over run. Or if you want to use this nice old equation, you can use that. So I'm going to use that equation. I'm going to use the slope equation for this just to kind of review that. So I'm going to call this x1, y1. This will be x2, y2. So my slope would be y2 minus y1. So 19 minus 9. And on the bottom, we have x2 minus x1. So that would be 8 minus 3. 19 minus 9 is 10. 8 minus 3 is 5. 10 divided by 5, that simplifies to 2. So my slope is 2. And then I have either point to pick from. So I can use either of these points. Let me just pick one. I'm going to use the 819. Why not? So y minus, you know what? I'm going to use the 3, 9 because it's kind of already labeled with the x1, y1. I guess it doesn't matter. So I'm going to do y minus 9 equals, my slope is 2, x minus 3. And again, I could have used the 819. I could have done y minus 19 equals 2, x minus 8. I could have used the other point. It doesn't matter. So let me just do b. Okay, so let's first find the slope. So let me just call this x1, y1, x2, y2. My slope, so y2 minus y1, so it'd be negative 5 minus 15 over x2 minus x1, 3 minus negative 1. Negative 5 minus 15 is negative 20. 3 minus negative 1 is 4. Negative 20 divided by 4 is negative 5. So my slope is negative 5. And to write in point slope form, I just need to pick any other point, any of these 2 points up here. So why don't I just pick this one? It's fine. So I'm going to go y minus y1, which I'm going to say y minus 15 equals, slope is negative 5, so negative 5, parentheses, x minus x1. x1 is negative 1, so I'm going to write positive 1. There you have it. Okay, so that's it. You just need a point and you need a slope. So I'll let you do C and D. For number 6, it's very much the same, just so that you understand. So after 3 years of ownership, it was 135,000. So that could be one of the points. And after 8 years of ownership, it was 175,000. So those would be your points, and you do the same sort of method that number 5 involved. But that's point slope form. So I'll let you finish the rest of that.